Welcome back to another exciting episode of Ruby for the Web. I am your host and your professor, Dr. John Baugh. This lecture we're going to be discussing control flow and methods in Ruby. So we're going to set up a project here. I've already gone to File Close on the previous project and File Open Folder on this project. Or it's actually over here, open folder, and found a folder or made a folder in the directory that I want it and named it lec2 Ruby control and methods. So I need the terminal here so I can get this created. Brings up a bash terminal. We're going to do bundle init, and it writes a new gem file. So you have to have had the bundler installed per the quick start guide that I had created. And what we're going to do now, once we've done bundler init, that creates the gem file, which basically can control or hold different gems that you might wish to install. So for example, for this one, I'll just put gem rspec. That's for things like testing, but you can also install debuggers and linting and things like that, which like we did the last time. This is just so we can keep in the habit of creating this gem file so we know how to use it. Okay, even if we're not using the stuff inside of it just yet. So bundle config, set path, vendor/bundle. Okay, that's going to ensure that the gems aren't installed globally, but just for this project, to keep it a little bit more isolated. And then we'll do bundle install. Okay, so it'll install everything that we need for that. And now we have a more isolated environment. Okay, so what are we talking about for this particular lecture? Well, we're discussing control flow and methods. So in the previous lecture, we explored Ruby's fundamental building blocks, which are numbers, strings, arrays, hashes, symbols, variables, constants, and basic input-output. We learned that in Ruby, everything is an object, and even simple values like 5 or true are instances of classes. Okay, again, if you're fairly new to programming, that may not mean much to you, but in general, what we're saying is that they're more complex, non-atomic elements like we might get in some other languages. So we can do things like call methods and things on even simple values like 5. Okay, so this week, this lecture, we're moving into a new theme, control flow and methods. So the control flow determines the order in which the instructions are executed. Programs would be boring and useless if they always just ran top to bottom without ever making any kind of decisions, right? So the methods, which is another topic, will allow us to package logic into these reusable pieces of code that can be called by name. Together, those two concepts let us write Ruby programs that are both dynamic, which means in this context that we get different outputs for different inputs, and organized, meaning that it's reusable and easy to read. Okay, so some general concepts first. I'm going to create a folder, or a file rather, called control-flow.rb, and there are actually 3 types of control statements, or categories of control statements. So programming languages, many of them, most I'd say, especially in the object-oriented or procedural type paradigms, will categorize control statements into 3 major types: sequential, selection, and repetition. Sequential is what we've seen so far. That means that the code just runs one after another, and that's the default. So if I put something like this, put s step 1, put s step 2, put s step 3, if I were to run this, I just get that printed out. No decisions made. It just goes one right after the other in the order that I wrote it. So it's executed in the order that it's written directly. And that's sequential. It's in sequence. So sequential, selection, and repetition. Next up is selection. For selection control, which is also called branching or sometimes decision control in different languages and different authors, the program will choose one path or another based on a condition. Okay, so for example, if I set, so this is a selection control down here. Okay, so if I do number equals 7, if number dot, now we're going to be careful here, but I'll show you in a minute. If number dot even, we say put s even, print it out, else put s odd, and then we have end there. Now this question mark at the end of this is actually not anything super special, but it is a convention in Ruby that is used at the end of what we call predicate methods. These are methods that are also called Boolean returning methods. They're Boolean methods that basically return a true or false value. They answer a yes or no question. So even question is a method that's built into the integer class. And again, this is just convention. It's not required for methods that are Boolean to have this at the end, but it is a Rubyist convention. So they want it to look more like natural language, like is the number even? Question mark. So again, this would also be a shortcut for the actual method name with parentheses, but remember if there's no parameter, well, even if there are parameters, you can forego use of the parentheses. But especially without any parameters, we often don't put parentheses. Okay, so let's see what this does. Make sure it's saved. That little white dot there means this file has not been saved yet. So Control S, and now it goes away. That means it's saved. All right, Ruby and Control Flow. There we go. So it'll say step 1, 2, 3 from my sequential description up here. Okay, and then we have the decision being made right here. And of course, since 7 is odd, that's why it's printing out odd. Okay, if we put an even value there, 8, for example, and save that, and then rerun the file, we get even. All right, pretty cool. Now, the next thing up is repetition. So for repetition control, these statements are often called loops. So I'm going to control the loop using a counter called count. Count is equal to 1. While count less than or equal to 3, I'm going to put s. Count is, use string interpolation, and then count plus equals 1, because we don't have an increment or decrement operator in Ruby like you would in, say, C++ or C# or Java. So this is more similar to Python, that we don't really have plus plus. So in some languages you would put count plus plus, but not allowed in Ruby. Okay, so let's run this and see what we get. So we get the stuff from before, step 1, step 2, step 3, which we did in sequence. We did that manually. We could have done that in a loop, right? So we could have had the value being printed out, the word step, and then the value, like we did here. So count is, and then count. So notice that this right here is the loop continuation condition. As long as the count is less than or equal to 3, it will keep going. Now, you have to put this in the body or this loop will go on forever, and that's called an infinite loop, which is a logic error. So it will theoretically never stop. Okay, so obviously the operating system or the runtime environment will eventually kill it, but that's what we're dealing with. So next up, in addition to our basic control or our basic general concepts with control flow, we'll come back and do some more, of course, but relational operators are our first deeper dive. So we're going to call this relational operators.rb. Okay, so what are they? They compare two values and return a Boolean, a true or false value. Ruby supports all of the what we call the usual values. So for example, those are from my notes. That's why it's got that dot there. Let me get this 1 second. We're gonna copy it and Okay, well, I didn't like that. Okay, we're going to get rid of these right here. And then I'm going to comment that out. All right, so this one right here is greater than, as you expect, I would believe at least. You have less than, so just the less than symbol. Greater than or equal to, less than or equal to, is equal to, not equal to, right? So those are pretty typical in other languages, but it also has a unique operator that isn't in a lot of other languages. This right here is called the spaceship operator because it looks a little bit like a UFO or something. And this one returns -1, 0, or 1, depending on whether the left-hand side is less than, equal to, or greater than the right side. And that's often used in things like sorting. It's syntactic sugar. You don't need it in order to accomplish a lot of the things that you might want to do, but it is convenient and helpful. Okay. So this is very similar to, say, a compare to method or similar methods in many other languages. Like Java has the comparable interface and you implement the compare to method. Okay, so let's do some examples here. So we're just going to directly print out stuff instead of using control statements. We're just going to say put s 5 greater than 3, put s 10, is 10 equal to 10. Notice there's two equal signs. We're not assigning a value. That would be one equal symbol. But here we're just comparing them. 7 not equal to 8. Then using spaceship operator, let's try 2 spaceship 3, 3 spaceship 3, and then 4 spaceship 2. All right, so let's see what this does. Relational. Okay, so let's see what that does. It'd be helpful if I saved it first, so it actually has code in it. All right, let's try it again. All right. Okay, so I had to clear it, create a new bash because it was like freezing. Okay, there you go. So we get true, 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 -1, 0, and 1. So 5 greater than 3 is true. 10 equal to 10 is true. 7 is not equal to 8, so that's true. And then we have 2 compared to 3. It returns a -1 because the thing on the left is smaller than the thing on the right. It returns a 0 for 3, spaceship 3, because they're equal. And then it returns a +1 because the thing for 4 compared to 2, because 4 is larger than 2. All right, pretty cool. Next up, we have logical operators. And so we've gone over arithmetic operators, things like plus and minus, and the compound arithmetic operators like plus equals, minus equals, multiplication, division, modulus. And we've gone over relational operators here, but we also have logical operators. So let's do logical operators.rb. Okay. And all right, so like relational operators, they are return a Boolean value, but logical operators also combine Boolean or what we would call truthy or falsy values, but we'll get to that. Whereas, well, when we do relational operators, they're often combined with logical operators to form more complex conditions. And Ruby provides the AND, which is this. So that's logical AND. Okay, we've got logical OR and logical NOT, okay, or negation. So we've got conjunction, disjunction, and negation, if you want some fancy, more formal terms. Ruby also has word forms, okay. You can also use and or not lowercase, okay, and they have lower precedence and are generally used in control flow, but not Boolean algebra. Okay, so they're just available and they are similar to the symbols. So Ruby, like some other languages, also acknowledges the idea of truthy and falsy values, so truthiness in Ruby. So in Ruby, only two things are considered falsy, false and nil. So the direct value false, which we intend to be false, and nil, meaning like kind of a null value, right? So some languages like JavaScript might consider, for example, an empty string falsy, but Ruby does not. Okay, or the value 0. Some languages consider the value 0 to be false, but Ruby does not. So everything else besides the false and nil are considered true, including 0, empty strings, and empty arrays. And again, that differs from, say, JavaScript or Python. So let's create oops, sorry, I'm using this file. Let's create some code here. So age equals 2, put s. We're going to say age greater than or equal to 18 and age less than 65. Let's try ready equals true, paused equals false. And I'm going to say put s ready or paused. We'll try put s not ready, see what that does. Then we're going to do some word forms. X equals true, Y equals false. We'll say put S, X, and Y. Put S, X, or Y. And then some truthiness. Okay, put S truthy if 0. And we'll see if if 0 is true, it will print, otherwise it would not. Put s truthy if empty string, and then put s not printed if nil. Okay, nil is kind of like null. So what we should get here, again, in Ruby, 0 and empty string are considered truthy. They're not falsy. This down here, nil, is falsy, so it will not print this. Now, let's try this. So we'll say Ruby logical operators, and we get true, true, false, true, true, truthy, truthy. You'll notice not printed doesn't print, right? Because this last one's null, or nil, according to Ruby. Remember that and means that both of its operands have to be true in order for the whole statement to be true. So if age is 20, then the age is greater than or equal to 18, and it is also true that 20 is less than 65. So since both of those things are true, this whole thing is true. Further, when we say ready is true, paused is false, put s ready or paused. Even though paused is false, ready is true. So with or, as long as at least one of its operands is true, the whole thing is true. So since ready is true, the whole thing is true. If paused was true and ready was false, it would also be true. If both were true, the whole thing would be true. What about if both were false? Well, if we change that to false and rerun it, we're going to get some different behavior, right? So it actually prints out that that is false. Okay. Now, what about put s not ready? Now, if ready is false, it's going to print out not false, which is true. Now, if I change this back to true like it was originally and rerun it, we'll get a little bit of a flip here. So it prints out false because ready is true, not ready just flips it. So this is a unary operator as opposed to the other two logical operators. The and is binary, has two operands, one on each side, right? Left-hand operand, right-hand operand, okay? And then the operator in the center. Same thing with or, left-hand operand, right-hand operand, and the operator in the center. But for not, it is unary. It only has one. It only has one on its right side, and that happens to be ready. That's its only operand. For the word forms, this was just to test and show you that the and or work that way, and then this is to show you truthiness example. Okay, let's go a little bit more into the selection control. So we're going to say selection.rb. And conditionals let a program make decisions. Conditional or selection control statements, also known as conditionals. Let the program make some decisions. So Ruby provides several ways to express branching logic. So let's start with score is 85. We saw something similar to this earlier when we were just doing our introduction. We'll say print out the grade A. Now else if is a little weird because there's no E. So just be aware of that if you're coming from another language. Python has elif, so there's no S. Other languages, you have two different words, else, if, in a lot of cases. So just be aware. Okay, and then else, this is the default, keep trying. So anything below a B, we tell them keep trying. So I guess if they get a B or an A, they can stop trying. I don't know. Anyway, we'll see what this does. So let's do this first, Ruby, and then selection, run it. We get a grade of B. Now, if they get a 77, let's see what happens. They get a keep trying. Now, what happens if we change this to a 98? So they got 98%. It'll say grade is A. All right. Another thing you could do is to use the unless. Okay. This is the opposite of if. Okay. We run the block if the condition is falsy, not if it's true. So it's equivalent to if not condition. So it's just syntactic sugar. So this is the unless. So it's opposite of if. We run the block if condition is falsy. Okay. So if we say hungry is false, okay, unless hungry, we put S, no snack needed, and then end. Okay. So again, this is equivalent to if not hungry. Okay. It's just syntactic sugar. So if hungry is false, unless hungry, unless instead of using if, so if the hungry is false, it treats it such that we would go into this. Okay. So we do go into this block of code. So it does say no snack needed. And again, that's equivalent to if not hungry. So it's just the opposite of what a regular if would do. Okay. Now, we also have a ternary operator. This is present in some other languages. So ternary operator, one second, ternary operator. It's a compact one-line conditional expression. So it's actually called a conditional in some other languages. Greater than or equal to 18. So this is the condition. The reason it's called ternary is that means that it has 3 operands. Now, how do we accomplish that? Well, the symbol is, it's considered a single operator, even though it has 2 different keystrokes. Okay, so it's got a question mark and a colon. And we can divide it into 3 by doing this. So we split the question mark and the colon, and we have 3 different sections. So the first segment is before the question mark. The second operand segment is between the question mark and the colon, and the third one is after the colon. So what does it mean? This is the condition that's evaluated, just like an if statement or an unless statement or what have you. And if it's true, if this condition here before the question mark is true, it returns the thing between the two, the question mark and the colon. Okay, this first thing, it returns this first thing here. If this is false, it returns the operand after the colon. So if it's greater than or equal to 18, it'll return adult, which means when we do put S, it'll print that to the console. If it is false, if age is not greater than or equal to 18, it'll return minor. Okay, so let's see that in action. It'll obviously show the other stuff as well. This is crashing a lot. Very strange. Okay, let's try it again. Give it a moment. All right, there we go. Ruby. So selection, RB. Grade A, no snack needed, and adult. So it is printing out adult because 20 is greater than or equal to 18. Now, if we put 12 and reran it, we will get grade A, no snack needed, and then minor. So this is the code we're focused on right now. We can also use case statements. This is like a switch statement in a lot of other languages. So case statement is good for multi-way branches. Okay, so let's say the day is Saturday, and we're going to say case day when Saturday. Okay, so if that day is Saturday, comma, Sunday, meaning if it's Saturday or Sunday, we put S weekend. Okay, now when Friday, we put S, we'll say almost there, dot, 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 and then else, just like an if statement, put S weekday. Okay, and then of course an end at the end. Now, run it again. At the end, we get weekend because the day that we are switching on, checking on, is Saturday. It holds Saturday. Now, what if we put Monday? Okay, that is neither Saturday nor Sunday nor Friday. Let's see what that does. It prints out weekday, as expected. All right, so we've done sequential. We've done a quick review of that. We've done logical and relational operators, and we've just done selection operators. So remember, there's sequential, selection, and repetition. That's the third major category of control statements. So repetition .rb. Ruby gives you several ways to repeat code. So we've got loops, and then we've also got things called iterators, which are idiomatic to Ruby. So we'll start with loops. So with loops, we've got the while loop. So we'll say count equals 1, while count less than or equal to 3, put S, count is, we've actually seen this one before, right? So we saw this earlier, but we're putting it in context now. And then count plus equals 1, and then an end. Okay, and as expected, if I say Ruby repetition, I get count 1, count is 1, count is 2, count is 3. Now we've also got an until loop. So this will repeat the condition until it becomes true. So it'll repeat it as long as it's false. Okay, so in many ways that's kind of similar to the unless. It's the looping version of the unless. Okay, so unless in selection control, we do it if it's false. Until means we do it as long as it's false. Okay, so we can write password equals empty password, and we'll say until password equals secret. Okay, maybe that's the secret password. Not a very good secret password. We'll say enter password, and then we have, now we're doing print instead of put S because we want it to not put a new line on the next line, so we're just printing it and then a space after, and then password equals get S dot chomp. Okay, so it can eat it, and then put S access granted. Okay, so if we get out of this loop, we assume that the access is granted. Now, in a real system, you'd want to make it more complicated and more secure, but that's what we've got right now. So let's do Ruby repetition again. Now it's waiting on a password. If I say the password is John, it'll ask me to enter it again because it loops with the until. It goes back up to the top because I didn't enter the correct password the first time. Now what if I put Bob, Sam? Oh, wait, I know. It's secret. Okay, then it breaks out of the loop. All right. You can also do, I'm going to comment that out so it doesn't interfere. I'm also going to comment this out just to make it a little bit cleaner. So this is the while loop. This is the, you know what? We don't need that many. Let's do it a little bit less. Okay, we'll just do 2n just so we know that that's actually supposed to be a comma. Okay, the rest of this can be uncommented. Let's do a loop do. Now, this is an infinite loop, always, but it's controlled with break or next. Okay, so if I say I equals 0, loop do, I plus equals 1, break if I is greater than 3, and then put S loop number using string interpolation, and then an end. Okay, let's run it again. We get loop 1, loop 2, loop 3, pretty much what we expected. We can change that number if we wanted to. Let's make it a 5, run it again just to show loop 1, loop 2, loop 3, loop 4, and then 5. Now, there's also a for loop, okay, in Ruby. But unlike many other languages, the for loop's actually rarely used in Ruby. Rubyists tend to prefer iterators, which we haven't covered yet. But if you want a for loop, for n in 1 dot dot 3, okay, we're going to put s for loop. We're going to put the string interpolation. Let's run this. We should get the regular loop and then our for loop down here. So works exactly as we expected. Now I'm actually going to make a second file here because it seems like that would make more sense. We'll call it repetition hyphen, well, no, let's do this. Iterators.rb is probably better. Okay, iterators.rb. Now, iterators are idiomatic. They're often like kind of functional syntax rather than going through maybe traditional control statement syntax. So they aren't the same as loops, okay, but they do looping or iterative behavior. So times is one. We've actually seen some of these before. So this will run a block n times, yielding a 0-based index. Okay, use this when you just need to do something, n times. So for example, 3, and remember these are all objects, right? 3 is an object. So I'll say 3 times, and then in curly braces I'll put inside these 2 vertical bars, I, put s, and then iteration number I. Okay, so let's run that. So we'll say ruby iterators.ruby. I get iteration 0, iteration 1, iteration 2. Okay, now that's because I told it to do it 3 times with this type of syntax. This is a kind of like an iterator parameter. That's what the vertical bars around it means, and then put s iteration blank. So every time it goes through this loop, this thing is the thing getting iterated or incremented, and then we can actually access it here. Okay. We also have things like each. Okay, this means visit every element. Okay, so arrays, hashes, ranges, etc. So I can create an array and then say dot each. Remember, because an array is an object. So that means it has methods, because everything's an object in Ruby. Now, we say do, and then this is again, a parameter for the iterator inside the body. We can use it, and it will represent each time. This time it's not really an index, it's representing the actual elements. So in some ways, if you're coming from another language, this is similar to a for each loop. Okay, but it's not a loop, it's an iterator. Okay, so we're going to say #n, and then obviously an end statement, because that's a little more complicated. Let's run it again. So iterators.rb. We get our iteration from our times, and then we get number 2, number 4, number 6, because it goes through that array. Now, do we have to do it like this? No, I could say my array equals 2, 4, 6, 8, 10, or something like that. And I could use the variable now. I could say my array. All right. If we run that one, we get 2, 4, 6, 8, 10. Okay, so you don't have to do it directly on the literal here. You can store it in a variable first if that feels more comfortable to you. Same thing up here. If this were just a number, okay, so if I said num equals 5, and then I said num dot times, you can do that as well. And we get it. Okay, so it goes from 0 to 4, because that's 5 times. And then this one is kind of the for each style. Okay. There's another one you should be aware of. There's many, but besides times and each, we're going to say each with index. So each by itself just goes through the elements of an array, but in some, or a collection of some sort, some data structure. But if I do need the index, which is the position within the collection, Ruby provides this each with index. Okay, so I'll take my array, okay, like I did earlier. I'll use that, each with index. do. Okay, so some of this is very similar so far. It's just instead of each, I put each with index, right? And then do, just like I did before. But now inside the vertical bars, I'll say element, comma, index. Now, those are not keywords, just like n is not a keyword up here. You could say, you could call that snuffleupagus and then put snuffleupagus there instead of n, and it would still do the same thing. So n is not magical. Okay, you could put I, you could put I wouldn't really make sense because it would work, but people think index when they see I. So you can come up with different names is kind of the point. Same thing up here. This doesn't have to be called I. It could be called count, could be called ITER, whatever you want, as long as it's not a keyword. So the general form would be like my array, each with index, and then code that uses element and index, and then you have end. Okay, so you have a collection on this side, a literal or a variable. Variable like this is fine. And then you might say something like put s, maybe, let's see here. Okay, we'll say element index contains and then element. Okay, and let's run this guy and see what happens. What do we get from this? Well, we get 0 contains 2, 1 contains 4, 2 contains 6, 3 contains 8, 4 contains 10. And that's actually what we expect. I'll do another one just to show you don't have to just deal with indices, or not indices, I'm sorry, integers. So let's do cat, dog, fox, okay? And then animals dot each with index do, and I'm going to say, sorry, this should be vertical bars, num, I don't like num, let's do animal, sorry. Animal and I. We could also call it index if we prefer. That's fine. But we'll say put s. We'll say number I. Oh, sorry. Put s in double quotes. Pound sign number I is number and then animal or pound sign animal. And that's pretty much what we expect, right? So let's see what the output is. Oops, something's wrong. What did I do? What did I do? Pound sign animal double quote. Something's goofy. Let me look for a minute here. Oh, there's no end. I need an end. Okay, there we go. Still doesn't like it. Okay, what does this mean? Animal? Oh, did I call it? Oh, I see. I called it animal instead of animals. It should be called animals because there's more than one. All right, there we go. It's a very handy, even basic debugging type output. So iteration, numbers, contains, and then we do the same thing but with strings. And you can see that at index 0 we have cat, at index 1 we have dog, and at index 2 we have fox. Okay. We can also work with ranges. Okay, so we'll say each with index with a range. Okay, so let's do this. 5 dot dot 7 dot each with index do num and I. Oh, I did it again. Num and I. Okay, for this one. Put s, we'll say index number. And then that leads to value. And that's the num. Okay, and then let's not forget the end this time. Too much Python lately, I think. All right, let's see what that does. And we get index 0 is value 5, index 1 value 6, index 2 value 7. So we can do it with ranges as well. You can also use something like an inline string array block. Okay, this is some syntax you probably haven't seen before. %W is just meaning we're creating an array of string literals. And this is to make it so that I don't have to put double quotes. Okay, I can just separate them with spaces. So Ada, Grace, and Yukihiro, and then dot each with index. And I'm going to do in curly braces here, name I, and then put s. We will say, since it goes from 0, let's say I want to number it from 1, I can actually use an expression. So I'll say put s, and then number sign, and then inside the curly braces I'll say I plus 1, because if I do just I, it'll say 0 is Ada, 1 is Grace, and 2 is Yukihiro. But I want it to say 1 is Ada, 2 is Grace, and 3 is Yukihiro. So even though the iterator or the iteration variable is starting from 0, counting from 0, I want it to look like it's starting from 1. Okay, let's try this. And we get 1 is Ada, 2 is Grace, 3 is Yukihiro. All right, pretty cool, pretty cool. Another thing we could do, you could use inclusive counting up to, or up or down, okay, using up to and down to. So I can, this is really wacky syntax, you're gonna either love it or hate it, but again, now I'm not numbering something, I'm using this number, okay, I'm calling a method on this number. So I'm saying up to 1 up to 3. And then in the curly braces, you tell it what to do. Okay, so n, we'll say put s, and then, put s up is print out the n, right? And then 3 dot down to 1. So 1 up to 3, down 3 down to 1. These are both completely inclusive, so it'll say 1, 2, 3. It will include the top number, and then down to will include the bottom number. So 3, 2, 1. All right, so we're going to say put s and then say down number is n, and then let's print this. We get up 1, up 2, up 3, and then down 3 down to 1 prints out down 3, down 2, down 1. All right, pretty cool. Next up, we have a discussion of methods. So let's work on that. So we'll say methods.rb. Methods are self-contained, reusable blocks of code. In Ruby, we define them using the def keyword and end keyword. Okay, the def opens it and names it, and then the end keyword closes it. That closes the method block. Even methods that look like standalone quote-unquote functions, if you're coming from another language like C++ that, say, allows global functions, for example, the methods are implicitly attached to an object named main in Ruby, and it's lowercase m-a-i-n. So Ruby doesn't have any true, what we would consider free functions or global functions. It only has methods. So some fundamental syntax. So let's try some stuff. So we'll say def greet, pass in the name, and we'll say hello # name. Okay, this is very idiomatic way to do it. And then when I say put s greet, I call it with the parameter, say Alice, okay, and then greet Bob, okay, for our networking friends. Put s, not put s, I'm sorry, Ruby, getting confused here. Okay, Ruby methods.rb, okay. When I run that, it says hello Alice, hello Bob, okay. So I'm actually gonna clear that and run it one more time. So we got, dang. Let me get it again. There we go. Ruby methods. Okay. Hello, Alice. Hello, Bob. And you might look at this and you're thinking, wait a minute. I used to put s, so this expects a string. This is returning a string, it looks like, right? Hello and then the name. But how is it returning anything? I don't see a return statement. Well, you could put a return statement, and it does the same thing. But a lot of Rubyists use this idiomatically. They recognize that the last evaluated value, okay, is going to be what's actually implicitly returned. Okay, so we can also do default arguments if we want to. We could, for example, put name, comma, punctuation as a second parameter, equals, and then maybe by default, I want it to always put an exclamation point, so it'll seem really, really happy. Okay, so, oops, gotta save that, and then, oh, I actually gotta use it, don't I? Okay, so I've got # and then punctuation. There we go. We'll run that guy, and we get hello Alice, exclamation point, hello Bob, exclamation point. What if I want to change that behavior? Okay, well, if I put s, greet, say Sam, and then I'll just make that regular, and then put s greet, say Dana, and we'll put a Question mark? Hello, Dana? You're not sure. So let's see what that does. And it does work. So by default, if I don't pass in a second argument, it will use the default parameter. If I do, like pass a second argument, that will take the place of the default parameter, and therefore punctuation will hold whatever that second argument is. In this case, a question mark. Okay. Okay, variable arguments. Let's do another one. I'm going to actually create another file just for this. So we'll call it variable args.rb. Def sum, and to do variable number of argument, you put a star or an asterisk in front of it, and then we'll say nums.reduce. Okay, this is, we're basically going to add them together. That's what nums.reduce does. It's another idiomatic iterator type behavior that we can use. We say basically start from the index 0 in this thing going up to I said index, didn't I? Started an initial value of 0. Okay, not an index. I misspoke. So sum, or whatever value nums, whatever value is getting returned here, starts with an initial value of 0, and then applies the addition to each of those values. Okay, so the asterisk in Ruby is called the splat. So if you picture, it's kind of gross, but if you picture like a piece of goo or slime being thrown against a wall, or a bug getting hit by a windshield, that's kind of terrible, but it splats. Okay, and it looks kind of like the asterisk. So in Ruby we call it splat. It means accept any number of arguments and pack them into this array we're going to call nums. All right. So the reduce injects or folds the array into a single value. Okay, so it reduces, it flattens this dimensional thing, like an array, into a single scalar value. So the first argument 0 again is the initial accumulator. So identity for addition. So the identity in addition would be 0. If we were doing multiplication, we'd do 1, for example. But the colon plus is a symbol for the plus method. Ruby treats it like a block. So on each step, it does the accumulator equals the accumulator plus whatever value we're on at that point. Okay. All right. So let's see what we get if we call this on a specific set of values. So I'm not passing in an array. If I did that, I would want to just use a variable to represent an array. But I'm passing in a variable number of values. So 1, 2, 3, 4. It doesn't know ahead of time how many I want to pass in. So I pass in 4 arguments. And if that's doing it again. So if I want to print this, I can just say Ruby, oops, sorry, probably should be in the terminal here, Ruby variable args, and it'll print out 10. Okay, now if I add a 5 to it right here, it'll print out 15. Not surprising, because if you add all of these values together, you get 15. We can also, as I mentioned, we can explicitly return. Okay, so I'll say return vowels.rb. We can explicit using a return value, or implicitly just return the last evaluated expression. So if I say def square, if I want to square the value n, I can just say n times n. So last expression is returned, and that is the last expression, right? With an end. Put s of square of 5. Okay. Also, I don't need the parentheses for put s. I can just do that. Square of 5. That should print out 25. But another thing, even if I use like string, I could do hello from main and do an end there. And then let's say what happens if I put s hello and then put s self. Now that's going to show us something in just a moment. But let's see what happens here if I do variable args, or not variable args, I'm sorry, if I do return vowels. Okay, we get 25, hello from main, and then main. Now, what was I demonstrating with self at the bottom? So I was just kind of throwing that in there so you can see that the self keyword in Ruby means the current object, and it's similar to this in many other languages. Notably, Python also uses self. So C++, C Sharp, Java all use the this keyword rather than self. But it recognizes that even though I don't see a class explicit here, um, everything belongs to this object called self. Okay. When I say put s hello, put s square will do its stuff and return a 25. I could also again put return explicitly, and it will do the exact same thing. Okay, but a lot of times in Ruby you will not see the return statement directly. Now I could also do, I'm going to create another one for this one. I'll call it void like methods.rb. So we'll say def greet name, and this one does not, it's not intended to create and return a value. It's just intended to do something. So in this case, I just want to print some stuff and then be done with it. So if I say result is greet Alice, now I'm capturing the result, but it's not really intended to be captured because greet is going to do its own work. But it's also not going to fail. If I say put s result dot inspect, that will actually return, should return a nil because this doesn't actually have a return value. So put s void, not put s, I'm sorry, Ruby void. We get hello Alice because it does what it's supposed to do. But then when we print result, we get nil. Okay, so don't see anything there. So if we put inspect, it'll actually force it to show what it's actually returning. All right, so as far as this particular lecture is concerned, that's what I have for you for this basic overview. Obviously, you should practice and follow other, if you're in one of my classes and you're seeing this video, obviously look for additional supplemental material as well. All right. I will talk to you later. I'll see you later. Bye-bye.